Hi, welcome to Azure User Group Sweden. Happy weekend, everyone. Hi, Håkan.
Hello, Jonah. Hi, how are you doing?
I'm great. It's sunny today outside, so it feels like the winter is over soon for us here mid north of Sweden. How about you there in
Uh,
Oslo?
According to the forecast, it will be the warmest day of the year so far, I think, plus 18
Oh,
degrees. Plus,
yes, yeah, I really look forward to summer. Yes, and to those that are tuning in to us live today, thank you for joining us, and I hope that you're having a great time tuning in. And today we will be having a session of one of our community members at Azure User Group Sweden, and it's an honor to have him with us today. And before we get started, let me just introduce ourselves to those that are joining us first time. So let me introduce Håkan Silvernagel. He is a community leader at Azure User Group Sweden. He is Microsoft AI MVP. He works as manager for big data and AI at Miles, and he is also very active in other communities like ambassador of Oslo AI, community leader of Norwegian .NET user group, and also an AI school called AI 42. And he is also a public speaker and a lot of things. So it's a great pleasure to collaborate with Håkan in this community.
yeah, thank you, Jonah. And it's also a pleasure to me to introduce Jonah Anderson, who is the founder of our user group. She is a Microsoft Azure MVP and also Microsoft certified trainer. She is also a mentor, a public speaker, a podcast host, and she works in her daily job as a cloud and DevOps engineer. And she is also writing a book, which is soon to be released here on O'Reilly. So,
Yes.
do you want to say something about your book, Jonah?
Yes, my book is about learning Microsoft Azure, and it will be a fundamentals book for developers and those that are still starting their journey with Azure. And it's all about Azure as well, which is our community. So really look forward to that. And actually, recently I found out what will be the animal of my book, so I was so happy. But I'm not gonna disclose it until it's time. Yes, that's great. Okay, yeah, thank you for the great introduction, Håkan. And before we kickstart our session today and introduce our speaker, let me just share to everyone about our community code of conduct. So we expect everyone to be nice and friendly, listen with purpose, and be thoughtful. Be respectful to others. Try to understand others, not criticize. Be curious to share your ideas in the chat or even in our after session ficas with the community, and be inclusive with your questions and comments. And if you have questions regarding our code of conduct, feel free to reach out to me and Hokan on LinkedIn. Okay. And do you want to share about our Azure Learner Heroes, Hokan?
Yes. So we are also very happy to be able to offer you a learner badge, so you can claim your learner badge here and also find out about the learning path. So you can see the Bitly here, and also you can scan this QR code.
Yes, that's right. And there's also a learning path related to the session today, which is about Azure Service Bus. And yes, and after session, we also want to invite you for our standard after session fika via Zoom to those who wants to continue the conversation after the live stream. Great. I'm excited.
Yes. Yeah, me too. So now
Yes.
it's time for us here to introduce one of our community members and also our speaker here today. So we're very happy to introduce Nikos Delis.
Hello, hello. Hi there.
Hi. Hi, Nikos.
Thanks
How
for
are
having
you?
me. I'm
You're
very good.
welcome. Yes, that's great. Yes. How are you
Greetings
today?
from Malmö.
Yeah, how are things in
Uh,
Malmo? Is it warm also?
it is warm. It is warm actually. It's very, very sunny and
Mm,
it doesn't blow that much as it usually does. So I don't want to jinx it, but it seems like spring is finally here.
great.
Yeah.
Yeah,
Yes.
so I would just like to give a more formal introduction here to Nikos. So Nikos Delis is a senior cloud engineer and also cloud evangelist, and he is a 6 times Microsoft certified and also senior cloud architect and a tech enthusiast. And he's passionate about software architecture and solution design. And he has 10 years of hands-on experience in software engineering and a focus on .NET-based solutions and also Azure as a cloud service, and worked on many types of applications, from small Windows Form tools to large-scale enterprise web-based solution. And the more he codes, the more he realized that his true passion is solution design and software architecture, regardless of tech stack and platform. And sharing knowledge and insights is the finest things he knows and the one he loves the most in the IT community.
Yes.
Thanks a
Amazing.
lot.
Yes.
Oh,
Yeah. Thank you.
that,
Welcome, Nikos. And it was a great introduction by Håkan. And we are so happy to have you. So, as we shared previously, April is a special month because we have our community members who never did a lot of public speaking before are volunteering to share their knowledge about Azure. And before we continue, I just want to like show that everyone, the friends that we have, Stefan is saying hello. We have Learn Asher with Nick saying hello. Ashish is all here today. Deepak is also here, and someone from Senegal is also
whoa.
a TV channel is tuning into us today. All right. Yes. And Nikos, I know that you are, aside from sharing knowledge, you're also doing podcasts, right? The Azure
I do.
Triumphs. Yes. Can
I
you share a
do.
bit about
Yes.
the motivation why you started it?
Well, to be honest, I got a lot motivated by you. Uh,
That's great to hear. Yes. That's
yeah, well,
great.
no, it is like that. That after working for a few years, then you start to realize that you can do a lot of things by yourself, but you can do even more things if you share your knowledge, and then it's two people doing the thing, or it's three or four, or as many as possible. So when you realize that, and you realize that sharing knowledge makes you better in what you do, then it wasn't hard to follow the path. And of course, I said in kind of jokingly, but I do mean that both of you and all the community members inspire me a lot. And the more content I see, the more content I want to produce. I think that we are in this thing together. All the communities all around the world. I'm very, very happy to see somebody from Senegal today,
Mm,
or wherever you are in the world. This is a magic that we're very happy to have in our industry. I don't see it in a lot of other industries.
mm.
So I like the climate. I like the whole thing, and it really makes me happy.
Yes. That's
Mm.
a very, it makes me happy to see how inspired you are, Nikos. And now you're on a virtual stage, sharing knowledge, spreading it out to others that are tuning into us or watching this recorded. Okay, great.
Thank
And today you will be sharing about Azure Service Bus, one of the Azure services I like using as well.
hmm Absolutely.
All right,
Yeah.
let's do it.
Okay. So now we have the presentation on. So I'll get started. Well, as Jonah mentioned, today we're going to talk about how to implement a fire and forget functionality using the Azure Service Bus. And let's start by stating the obvious that it's not a bus, okay? There's nothing with collective traffic. There is nothing, no real bus at all. In fact, the Azure Service Bus is a message broker. Before taking the bus, although we do have the introduction, let me just shortly mention a few things about me. My name is Nikos Delis. My title and my certification have already been mentioned. I wanted to say that I I also have a blog called ndtechnique.com where I publish content about Azure, about anything that I do in my everyday work and I find a little bit challenging, then I think that maybe I could help someone that also would find it challenging. So I try to write a small post or something and publish it in my blog. I also do a podcast, as mentioned, called Azure Triumphs, where I interview people who have done successful projects in Azure, and I ask them about their experiences, about what they did in that specific project, without breaking any NDAs, of course. And last but not least, I try to be as active as I can in Azure communities such as Azure User Group Sweden, the one we currently are on. And I get a lot of knowledge from there. I try to share my knowledge as well. And I would like to invite everybody who's watching this video live or in the recording, do not hesitate. Become a member of the community. You don't have to actively commit something. I'm sure you will get a lot, and if you feel like that, then why not share something? Now, getting into the core presentation, the subject of today, I'll just run through the agenda. First of all, I will try to explain what is the Azure Service Bus. Then we will try to compare it with Event Grid and Event Hub, which together with the Service Bus are the three services that Azure uh, proposes to use for implementing a message-driven architecture. We will see how we can put Service Bus in our architecture and what advantages do I get. We will also talk about the first in, first out pattern. We will talk about how we can schedule message deliveries. And of course, the presentation wouldn't be complete without a reference in the dead letter Q, where messages go to die. And last but not least, I will try to mention a few pitfalls. I will try to mention a few pitfalls to avoid, at least the ones that I have been into. Okay, well, getting started with Azure Service Bus, the 101, as I like to call it, and if you Google about it and or Bing about it, and you see how Microsoft describes it, then they say that it is a fully managed enterprise message broker with message queues and publish subscribed topics in a namespace, and the Service Bus is used to decouple application and services from each other. So what this essentially means is that Service Bus is going to be used as a man in the middle in a communication between two services. I know that a lot of people are working with integrations where one system has to communicate with another system. I don't think there are a lot more common scenarios like that. This is one of the most common. And in such cases, you have two dependencies. So for this integration to work, both systems must be up and running. So to relieve you from this dependency, you can put a message broker in the middle, where the one system is sending messages and the other system is picking those messages. Now, as you can see, Service Bus provides two kinds of queues. Let's call them queues. The one is a queue and the other is a topic. And the difference between a queue and a topic is that a queue has one sender and one receiver, while the topic has one sender, but it has multiple receivers. I have taken those images from Microsoft Learn, but there is one thing I don't like. I don't like the word receiver because, as I will explain later, in Service Bus we don't have receivers, we have subscribers. So the one endpoint is going to send a message, and the other endpoint is not going to receive a message, it is going to pick a message from the subscription, from the topic, from the queue. This is an important detail and an important difference from the other services. I also want to mention that Azure Service Bus is one of the oldest services in Azure. It has been in use for over 10 years now, and they only have lost 7 messages throughout all those years. can you imagine how good is that? Like, I guess they have had trillions of messages delivered, and they only have missed seven. I mean, that's one thing they can brag about. Uh, Fair enough. And of course, some details. There are various tiers in that service. There is the basic tier, or I think it's called classic. No, I think it's called basic actually. And this is the cheapest one. Actually, it's free until a number of messages, but it is totally not recommended for use other than development and testing. We have the standard tier, which is more modern, more trustworthy, but still not recommended for production. If you do solutions in production, then Microsoft recommends using the premium tier, which is a bit more expensive. In the other tiers, you pay for as much as you use. While in the premium tier, you have a fixed price, and then you can't pay more than that if you break some limits which are pretty much unbreakable. Then there are some quotas as well. The maximum message size can be up to 256 kilobytes for the standard tier or 100 megabytes from the premium tier. The queue or the topic size can be between 1 or 5 gigabytes for the standard tier and 80 gigabytes from the premium tier. And if you're wondering how can the queue grow, well, as I mentioned before, Service Bus is used to decouple applications. So the sender may send as many messages as they want, but it doesn't mean that the messages will be picked immediately. So you have to put those messages somewhere, and that somewhere is storage, kind of storage, and this can grow, grow, grow up to a limit. So this is what that limit is. And since we're talking about JSON messages and not images or stuff like that, or messages of 256 kilobytes, we have a pretty huge number of messages that can stay in the queue or in the topic before it starts to become a problem. Another limit is that you can only send up to 100 messages per transaction, and this stands both for synchronous and asynchronous communication, and that you can have maximum 10,000 topics or queues per namespace. Namespace is actually a grouping term, and when you create an Azure Service Bus instance in your Azure account, in your resource group, then what you create in essence is a namespace, an Azure Service Bus namespace. There, of course, there are more. You can find all of them in Microsoft documentation. Other interesting features about Service Bus is that it is one of the most interconnected services in Azure. It works very well with Event Grid, with Logic Apps, with Azure Functions, Power Platform, Dynamics 365, Azure Stream Analytics for those of you who work with IoT. This is a very important one. And if you don't have any one of them, or if you are trying to send messages or pick messages from outside of Azure, then Azure Service Bus even exposes an API, which a RESTful API, which you can use, you can consume, and send messages that way. So it isn't only available and optimized and interconnected with all those services and even more than those in Azure, but it is even available from whatever kind of application you have. You can use a number of SDKs to send messages to Service Bus, including but not limited to C Sharp, Java, C or C++, Python, PHP, Go, JavaScript, and even more. Of course, it is fully managed by Microsoft, and we should not underestimate that one because there are a lot of message brokers. But if you try to set up one by yourself and if you try to manage it and to host it and to keep it alive and scale and parallelize, then you will see that it is a huge pain. And having Microsoft manage it for us saves us from a lot of headaches. And as I mentioned earlier, Microsoft are very proud about this product. They see it as an industry leading when it comes to reliability and availability. And you understand that if you're going on an architecture where you put a middleman to decouple applications, then you are actually implying that the applications might be shut down whenever possible, and it's no worries because the middleman is going to be up and running. So it takes a lot to build the trust, and it takes a little to lose it. And Microsoft and Azure have succeeded to create a product that is considered to be one of the most reliable and available products in this area of the market. Further on, as I mentioned previously in the agenda, I wonder myself, and I also hear in this question a lot, what is the difference between Service Bus, Event Hub, and Event Grid? And those three services together consist the services that that Azure offers when it comes to message-driven architectures. So starting from the right side of the grid, we see that the event grid is the one that is most different from the others because while Service Bus and Event Hub use the sender subscriber model, the event grid is using the push style distribution model, which means that the event grid will see that the message gets delivered to its recipient, while the other two only make sure that the message is delivered to Service Bus and that it is picked, I'm sorry, that it is picked by the subscribers. So when should you use event grid? Well, if you want to react on something and if you want to make sure that something will happen, then I suggest you use the event grid. So the event grid is also used quite a lot by Microsoft itself. Example-wise, for Azure function triggers, event grid is what triggers functions and other similar stuff. And it is used to send discrete events. You cannot accumulate them, you cannot aggregate them in any way. They have to be um, completely autonomous and they have to be sent and intended to be processed by themselves. Then we have the Event Hub, which is the one solution you should use if you have high volumes of data. And this is why I don't have the IoT hub in this slide, but it is very, very similar to Event Hub, and it also is designed to be able to receive and process many, many messages, a high volume of messages, millions of messages per second is no problem at all for the Event Hub. But the difference here again is that the Event Hub will receive a message and it will not send it somewhere else, but it will wait until the message is picked by the one who is interested in picking it. And it offers features like reading messages, like you don't have to mark a message as processed when it is processed. It can be reread again and again and again, and this is a very useful feature if you're building, like if you use an Azure Stream Analytics job, and during the time that you're configuring it, and you want to stream the same messages again and again and again. And this is not always an option, so you can ask the Stream Analytics job to go back in time and reread the messages that were sent an hour ago or something like that. So you would use the Event Hub to um, to react on something that has happened, like a sensor sending temperatures, and we monitor all of them, and we react when the temperature gets over 40 degrees or something like that. And we can also use the Event Hub to aggregate messages and like to take the average temperature or something per hour, then Event Hub would be a very good solution. Or if you want to do anomaly detection and to perform an action like that, then you have to check a lot of messages in the same time. And last but not least, in the topic of the day, the service bus. This is also different, very different from Event Grid and quite different from Event Hub. It can also get a high volume of messages. I would say that the biggest difference between the Service Bus and the Event Hub is that the one is getting events and the other is getting messages. And okay, well, they are kind of similar, but I would say that a message is an event with a body, like it contains information inside of it. Technically, the event can also contain some information, but we should treat the events as discrete, as entities of their own, and we shouldn't care about information inside them. The events should be like this happened, this happened, this happened, while a message can contain information about exactly what happened. So you could use the service bus to create a new task, like if an order is created and you have to ship it, or if I don't know, if time goes and you have to create a log or something. Those are scenarios where the service bus is going to be very, very useful. And as I mentioned in the beginning, it has queues and topics, and it follows the send and push methods, the send and subscribe methods. So you don't have recipients, you have subscribers. And we also, I guess it's a good time to mention another important feature of the topics, which is that one topic can have multiple subscribers. And if you send one message to one topic, then it will be delivered in its subscription. So it's not like that you have one topic and 10 subscribers, and the first one who picks it is the one who keeps it. Instead, it is going to be like that every subscriber is going to pick the message for themselves, they're going to process it from themselves, and so on and so forth. So summarizing, you use a service bus to decouple application and to react if there's a new task or something. You are using the Event Hub to react on something that is happening, and you're using the Event Grid to ask the recipient to do something. Going forward with the architecture, as I mentioned earlier, the Service Bus is very well interconnected with multiple other Azure resources. So as we can see in this slide, I have created an imaginary architecture where I have a storage account containing files, maybe containers or blobs, and then an Azure function is triggered by a blob being created, and it is sending a message. You see the message here to the service bus, and then you have another Azure function which picks that message because it has a subscription on the same topic where the first function sends its message. It picks the message and it saves it in another storage account. Or another scenario, we have a logic app which is executed, which is triggered by something, maybe an HTTP request or something like that. It gets the request body, it puts it inside a message, it sends it to the service bus, and when the other function picks the service bus, and I guess I should mention that there is a specific trigger for Azure functions to pick messages. Then it picks the message, it processes it, and it sends it farther on to the data factory. And last but not least, one which I use quite a lot, as I will show later on also, is the API management, which gets a request to an API endpoint. This is the request body in this little image, and it is using the API that the service bus exposes to create a message and send it using a post request. It acts as a usual RESTful API. There's no difference at all. And by getting the response back from the service bus, you do know if the message was sent or if something was wrong. Example wise, in the standard here, There is no guarantee about, or it's not a matter of guarantee. You do know that you might have slight interruptions or a bit higher latency sometimes, and you have to take care of that. So by checking the response of the API, you know if the message was delivered or not. And in many cases, you have to try again later, or you have to try resending it, and so on and so forth. But in any way, the API management is sending a message using the API, and another function is picking that message and it is doing something appropriate. Let's show now an example of a real application, which I do as a hobby project. We do have, let's say that I have built an application, a native application using Maui. And this application is sending a request to API management, a main point there, and then this itself calls the backend Azure function, which processes the body and creates a message, and it sends a message to a service bus topic. Then I have three functions and a web application which are picking those messages using their own subscriptions. So the first function has subscription 1, the second has subscription 2, the third has subscription 3, and the web application has subscription 4. So all of them are picking the same message. One is sending it to Postgres database, the other one is creating a file in the file explorer, the third one is sending it to an AI model to perform anomaly detection or something like that. And the web application is displaying the message to the user. Um, so as you can see, what would happen if we didn't have the service bus in the middle is that Azure function would be responsible to sending the message first to this, then to that, then to that, and then to that. And if that is down, then nothing works. Or if that is down, then the message is never saved in Postgres, or it is never saved in the file structure. Or in every case, if one integration is down, then it doesn't work at all. When we have the service bus in the middle, then we have the luxury of waiting for the application to react, to come alive again, and to be able to process the message. Also, if the sender is down, then this doesn't mean that the subscribers cannot pick messages and continue working. So it is a win-win. We have successfully decoupled the application by putting the service bus in the middle. I think that now it is a good time to do a small demo. I will leave this QR code in the screen for a few seconds, let's say like 10-15 seconds, and please take up your mobile phones, use the camera and scan it. Don't worry, it will only get you to another function and you will get a message. I am also going to do it myself to make sure it works first of all, but even to create some messages. Very good. I hope some people have done it by now. And let me show you some code. Um, okay, so what you just did by scanning the QR code and by um, getting to the website, or actually it's not a website, it's a URL which sent you some text as response, is that you called another function which I have published in Azure, and it looks like that. I will try to zoom in a little bit to make it easier to read. So that's the one. It got a GET request, and from the body, actually it didn't care at all about the body. It generated the random funny name. If you refresh your browser, then you get another random name. Then I got the connection stick to the service bus from my local settings, And then I have the topic name. I create the client to be able to talk to the service bus, and this is coming directly from the SDK. So this is the way Azure functions are interconnected to the service bus. I created a sender using the client. I created a message by converting the text to bytes. And last but not least, I used the asynchronous method to send the message to the service bus, and I gave you the response with the friendly message you read. Thanks a lot for attending my session. Random funny name. Let's hope it works. So this was one function, the one that sent the message, and I have written another one, the one which is called subscriber, which is responsible for picking the message and printing it on my screen. Now, as you can see, the function is not running, but we still were able to send the messages. So exactly what I mentioned earlier, we don't have to worry for both systems being up and running. It's enough that one of them is, and then the service bus is going to keep the message for us while the other one is getting ready. So let's see what happened. If I go to um, my service bus namespace, as you can see, I will go out to the research group, and here I have created a service bus namespace, and it has a couple of topics. Actually, only one, the one that is called default. Inside of it, I have some subscriptions, which is called default as well. And if I use the Service Bus Explorer, and it's loading, and I have to select the default subscription, the one I mentioned earlier, then I can see that I have 7 messages waiting. Now I am in peak mode. Being in peak mode means that you can see the message, but you do not mark it as completed. If I were in receive mode and I got the messages, then they will disappear because you can only pick them once per subscription, of course. So let's stay in pick mode and pick the messages from start. And as you can see, I see my numbers here, and if I click on one of them, then I see the funny name that was automatically generated, Allegitated Bratton, or Sleepy Jennings, or Jovial Summit, or Pensive Mortal Tini, or something like that. So what I expect to happen when I run my subscriber function, which as you can see has a service bus trigger, listening on this topic and using this subscription, and the connection string that comes from, I can show that, I will delete everything later, so there is no worry. As you can see, I get the connection string from the settings. Then I am going to pick this message and I'm going to display it on my console. So if I run this, let's see what happens. I expect it to react immediately, and it does. I maximize the window. Uh, Maybe I can even make the text a little bit bigger. And as you can see, all the messages that we had in the service bus are now being displayed. So if I go back to Azure, to the Explorer, and I refresh, then now I have none. And I will try to move this here to show you how quick this thing is. And this is the function that you have been calling. So if I call it again, then as you see, Jolly Yellow or something, and it appears directly here. If I refresh again and again and again and again, then the moment the subscriber picks the message, oh, I guess someone, oh, I had another function that keeps the whole thing alive. The moment someone sends a message, the subscriber is picking it. So this is how fast the things are done. And let's close it again and generate a couple of messages again. And as you can see, there is a couple of those. Now, if I go back to my subscription and I pick from start, then I can see that there are still messages here. So Uh, this was a small demo I had for you today, and I did show you some code, but you need more than that. I did show you how to create a sender and a client and how to send a message, but there is way more than that. You have to react on the response that you get from Service Bus, and you have to do other stuff. You have to retry, you have to abandon, or you have to send a message to the dead letter queue if you cannot pick it or if you cannot process it. And information about all of those techniques is going to be found in Jonah's book. Jonah, in the emails I could find in the GitHub repo, I found this cute bird. You mentioned that it's going to be another animal, so don't take this for granted. You might see another animal when the book comes out. I'm very, very curious to find what it is. But what I wanted to mention is that there's going to be actually a whole chapter or a whole section about Service Bus. And if you want to learn more about it, and if you want to know all the tricks and tweaks, then don't miss the opportunity to get and read that book. Going further on, the first in, first out pattern, which can be implemented using Azure Service Bus. Um, First of all, what is this pattern? Obviously, you send a message and you want it to be delivered first, and you send another one and you want it to be delivered second. Well, how do you do it? There is one term called session, which you can put it in a topic or in a subscription, and you have to implement it in your message, of course. And by putting session IDs, like you see in this image, we have the session 1, 2, 3, 2, 1, and so on and so forth. Then Service Bus is putting the messages in order so that the messages are delivered in the order that they are received. Then I do have to mention one little trick here, which is the idempotence, meaning that the messages can be delivered multiple times and they can be picked by multiple subscribers, meaning that if you have database operations and you do an insert and a delete, and the first agent picks the insert and the other agent picks the delete, then obviously you have an issue. So you have to make sure if you're using multiple subscribers using the same subscription, that you have to make sure that only one of those picks the message. Or maybe you should rethink if you do want to implement the first in, first out pattern at all. I have another QR code here. By scanning it, you get to Microsoft Learn and information about this and even more patterns and how to implement them using the Service Bus. Oh, I also wanted to talk to you about the scheduled message deliveries because the SDK offers us two ways to send messages and them to be delivered exactly when we need. So the first one is to set a value in the field called scheduled and queue time in UTC. And the other one is to pass both the message and the scheduled time via the schedule message API. I will show you very, very quickly in Visual Studio how to do both of them. So the first way, the first way using the scheduled and queue time field is by, and I will zoom even more actually, by putting a datetime object here, datetime offset. So in this case, I have now plus, let's make it 5 seconds, and I will run this thing. And now what I expect to happen, okay, let's see. Let's put this one here. Oh, I see I had some messages while I was doing, that's good. So if I go back and I call the sender this time, then as you can see, it will wait 5 seconds before giving me the message. So let's call this one. And Tender Raman, it's called. 5 seconds later, here it is. Let's take another one. Prickly Almeida. 5 seconds later, here it is. Okay, 5 seconds is very short time, but this is how you. It wasn't shown very well, but this is how you do it. I don't want to waste a lot of time. And to implement the second way with the other API, you just called instead of send message async, then you call schedule message async, sending the message and the date time. Now the hours, for example. Now this will be sent. This will be sent immediately, but it will be available 1 hour from now. Going back to the presentation, and I'm close to the end. I want to say a few words about the dead letter queue. This is a special queue which is available in the service bus, and it is used to receive the messages who were not able to be processed by their subscribers. And there is multiple reasons why a message can get there. First of all, it could be too big, so that the header size is exceeded. As I mentioned earlier, there is a limit about how big a message can be. So if it becomes too big, then it cannot be processed anymore and it's moved to the dead letter queue. Another reason is that the time to leave option can expire. There is a feature in all messages called time to leave, and it has a default um, value as well. And when this time is passed, then the message is considered to be expired and it's not available for pickup anymore. Then if you configure your topic as a session demanding one and you send a message without a session ID, then it will be automatically be moved to the dead letter queue. There is also a limit about how many hops a message can take between subscriptions. So if you jump for more than 4 times, then you get into the letter queue and this is to avoid circular references. And there is also a max delivery count which can be configured. And if this is exceeded, then again the message gets to the dead letter queue. Last but not least, a few pitfalls I have fallen into and I would like to recommend that people avoid is that if you're using the API, you should be aware that there are connection limits. There is a number of messages you can send per minute, and if you exceed that, then you will have to wait for the minute to pass before sending new messages. And this applies to the connectors available for between the service bus and other services, such as the logic apps, example-wise. So keep in mind that you're not free to bomb the service bus as much as you want. You have to be smart and you have to configure your application so that you don't break those limits. Otherwise, you're going to have bottlenecks. Another issue there is that there is no emulator yet. It has been reported to Microsoft that there is a need of it, but to be honest, I feel that I need it because I don't want to be dependent on having another subscription all the time. If I had one, I would use it a lot. I guess that the reason one is that the service bus is evolving all the time, and they don't have the ability or the time, or maybe they don't see a lot of value in it in creating an emulator, because if they make one, they want it to work good and to reflect the service bus that really exists. Another issue, of course, you find it out directly, is that you can only set text, no media. And I know what you're thinking, that you can convert an image to a base 64 string, but be very, very careful with what you're doing, because those strings can be really, really big. Then, of course, it is a single point of failure if you use it in your architecture in that way. So it is very reliable. It is, let's say, always available, but it is a service which is somewhere. And if it fails, then most things fail. So you have to be aware of what you're doing, and you have to make the disaster recovery plans, and you have to think of what happens if for some reason service bus is not available. If you need low latency, then you have to use the premium version of Service Bus. I know it costs more, but if you do have the need, then low latency is guaranteed there. You get low latency even with the standard version of the Service Bus, but there is no guarantees. And in my experience, um, pretty much every day or every couple of days, you will get like half an hour or a quarter of an hour of bad latency, of a bit higher latency. And I'm not talking about minutes, I'm talking about seconds. But if your application needs to be instant, then you have to go with the premium one. And last but not least, and I avoided to show you how I connect to the service bus. Um, the service bus offers you shared access keys if you want to use them. I know it makes things simple. I know it is easy, but it is not safe because shared access key can easily be committed to Git. It can easily leak somewhere, and you can lose it, and then you have security issues. So what you should do instead is that you should use the managed identities and role-based access control. So there are roles for Service Bus, such as Service Bus data sender or Service Bus data owner, which can do more, of course, or the receiver, and use those roles, apply minimum rights. So give to your applications only what they need, not everything, not all access, only the access they need to be able to perform actions with the Service Bus. And with those words, I would like to thank you a lot for attending my session. Thank you for being a member of this community, and Jonah and Håkan, thanks for inviting me. I had fun. I hope you had it too.
Yeah, so thank you so much, Nikos. It was a really great session.
Thank you.
Yes, it was great. Thank you so much. I like the way you talk, because it's like you feels like you're in a ambient environment. Yes, thank you so much.
I
Yes, for
might
that.
be.
Great. Yeah, thank you. Great session. I learned a lot about Azure Service Bus, and I'm sure our audience as well. We do have questions, Hokan and
Yes.
Nikos.
Oh, fantastic.
Yes. Do you want to ask the first question, Hokan?
Yeah, sure. So we have
Yes.
a question is from Adedulapo Okunsanmi. He says, I currently use Azure Redis for catching a message queue. Would Service Bus be a better implementation? And he also clarifies that the Redis is front of a database.
Mm, it depends. It could be used instead of Redis. Well, Redis is actually it's some kind of memory. So you use a dictionary style of, let's call it a database, which has very fast writes and very fast reads. And if you have that needs and Redis suits you, then sure, go for it. Then it depends a lot on the volume of messages you have, and if you want to optimize your costs, then keep in mind that Service Bus will give you 1 million of transactions for free every month. That's quite a lot. So if you have lower than that, then you can bring your costs to zero, like totally zero. So yeah, it depends a lot on what you're doing exactly. But it could be an option, absolutely.
Mhm.
Okay,
Okay.
great. We have a next question here. Thank you for answering, Nico. So,
Mhm.
next question from Aman Basiston. Hi,
Mhm.
if a topic, for example, has two subscribers,
Mhm.
now let's say if the first subscriber received the message, then the second subscriber cannot get the message. What to do so both can process the message?
Well, you cannot do anything because this is not, you do not have to do anything because this is not the case. If you send a message to a topic, and then every subscription will get a copy of this message by default. You do not have to configure it somehow. This is how it works out of the box. What you can do is that you can filter out some messages, because what is more likely to happen is that you're going to have subscriptions that are not interested in some messages. and I didn't mention it, but every message can have metadata and custom data, and you can use like a type, message type field or something, and to call it a message type, I don't know, an order. And then the subscription that is listening and that it is expecting to pick messages which are kind of orders are going to pick those messages. And if you get a message with another type, then that specific subscription is not going to pick it. But if you don't use any filters, then every subscription is going to pick every message. When I do implementations, I always have one subscription called verbose without filters. So what this does is that it picks every single message. And I have like a maximum time to leave for the message, like 3 hours or so that it doesn't get overflooded. But the other subscription also get copies of the message if they want them to. So in your question, you don't have to do anything. Every subscription is going to get a copy of the message unless you want something else.
Okay.
Okay.
Yes, thank you so much for that. I have one question. I didn't post it in the chat, but my question is let's just say we have someone in our audience or watchers right now that are new to Azure and still starting to learn about Azure Service Bus. What is your practical advice as a developer and architect to get started and try to understand the basics of this to develop with Service Bus?
Yes. Well, first of all, I would advise you to understand the message-driven architecture. Most of us who design software and who design software for cloud are used to build microservices. And the microservices most times talk directly to each other. So if you have a database microservice, then all the other services are going to consume the database as a microservice directly without anything in the middle. When you have to start issues with some of those services, then this is when you need the service bus or another kind of message broker. And how you get started? Well, it's not that hard, actually. Microsoft has a perfect documentation. And also, once again, Jonah's book is going to be a good way to start learning about Service Bus as well as other resources.
Yes, you're selling a bit about my book. It's like
Well,
you're my co-author. You read
I have
some.
I have read
Yeah.
some, and
Yes.
I wish that I had read it earlier.
Yes, that's right.
Yeah.
Yeah,
Yes,
yes.
yeah. So I also have a question, Nikos here. So what if you just want to try it out? Do they have like a free tier that you can try, and what are the regular cost if if you use it in a more real world scenario?
Absolutely. The basic tier is completely free, but you only get a specific amount of messages. I don't have the number in my mind, but it's a quite big one also. It's more a matter of reliability, that the free tier, the basic tier, is not going to be reliable at all. So you will have issues when you send your messages and they are not received or stuff like that. Then the standard tier will also give you a very big amount of number of messages for free to pick and to send. But after some millions of messages, then you do pay something very, very little. It's not the cost that will make you move to the premium tier. It's the need for low latency and high availability. Uh, in my solutions, I'm completely fine with the standard tier, and we have in one specific project like 1.5 million messages a day, and the bill doesn't get higher than 10 crowns, Swedish crowns per month. That's like $1 per month. If we had the premium tier, then it would cost $6.99 per month. That's a big difference. But then
Mm.
we do have issues with the latency, and we do have issues with the service bus not being available for very, very short periods of time. And we handle those issues by coding the solution to retry again and again and again until the service bus has been available again. So it's a matter of where you want to put the effort. If you want
Mm.
everything to move smoothly and no issues at all, then go for the premium tier. It's the one that suits you best. If you can cope with some very little trouble, then the standard tier is going to be dramatically cheaper than the premium tier.
Yeah. Okay. Great. Great answer. Thank you. I think
Okay.
premium, just to add, I think premium tier is ideal for production workloads. And if you're just a beginner
Mm,
learning, then it's more practical, of course, to start the standard or the cheapest possible to say yes. Yeah. Thank
absolutely,
you.
yeah.
Yes, that's right.
Mm,
I think we don't have any more questions,
Mhm.
Hokan. Yes, and we're also at the top of the hour, and but I want to share to everyone that we got a feedback from Ashish. Great
oh,
session, Nikos,
thanks,
and
Ashish.
also Amar also said great presentation.
Thanks a lot. Thanks a lot.
Yes,
You're very kind.
yes, that's right. So we do have a fika, like a Zoom meeting for 15-20 minutes to those who wants to continue the questions or conversations with Nikos. So
Mm,
feel free to join us. Let me just send the link, the bit.ly link for that Zoom link, which we will connect to later after this live stream.
mm.
But otherwise, Håkan, do we have anything else for Nikos before we ask him to like share about his upcoming events or contact details?
No, I don't think so. I can just show it here too also
Yeah,
for
that's practical.
yes.
I did that actually also on the planner. Great,
Mhm.
thank you, thank you. All right, Nikos.
Mm.
If our audience or your followers want to reach out to you about this topic or anything about Azure, how can they reach out to you and listen to your podcast? Of course.
Oh, thanks for asking me, Jonah. Well, I'm a very easy to find guy. You can find me in Twitter, LinkedIn, or in my blog. Actually, if you scan the QR code that I showed earlier, if you did scan it, then you will get to my blog and get all the contact information. My Twitter handle is Andy Technique, and my podcast is called Azure Triumphs. And yeah, I think you can see it right, let's say here. That's the one. And yeah, just drop me a line. I'm very happy to speak with everyone. If you have feedback, if you have questions, whatever, let's connect and let's talk.
Okay, that's great. Thank you so much for that. So I think it's time. So I hope to see everyone on our after session fika.
Me too. Grab a coffee,
Yes,
guys, and
yes.
see you in
Have
a couple
a
of minutes.
yes. Have a great weekend, everyone. Enjoy the weather that we have today. Bye
Bye
bye.
bye,
See
everyone.
you next time. Bye.